All right, I'm back. We are on page 325 out of 329. We are getting very close to the end. What do we have here? We have a little bit of review about asymptotes because it's been a little while since we talked about them. They're really important. I just want to circle back to them, make sure that you remember everything about them that you're supposed to, because you cannot afford to forget anything. So calculus is amazing. And for students, maybe a little annoying because everything that you learn every day will apply every day going forward. It's not a class where you're like, oh, what's going to be on the quiz? Everything's going to be on the quiz. Once you learn it, it could show up whenever. So let's review this and make sure that it's still something you remember. So write down the various limit combinations that lead to asymptotes. All right, vertical asymptotes. All right, so those were, you have a finite value, and then you're going to go to infinity, negative infinity from either direction. So I'm going to say x equals c is a vertical asymptote if, one, the limit as x approaches c from the left of f of x equals infinity. Two, the limit as x approaches c from the left of f of x equals negative infinity. Three, the limit as x approaches c from the right of f of x is infinity. Or four, the limit as x approaches c from the right of f of x is negative infinity. So any of those four. Doesn't need to be all of them. It only needs to be one of them. If one of those is true, then x equals c is a vertical asymptote. Definitely. All right, a horizontal asymptote, a little bit different, right? So usually it's y equals k is horizontal asymptote if the limit as x approaches infinity of f of x equals k, or the limit as x approaches negative infinity of f of x equals k, where k is a finite number. So those are your options, and so those are your justifications, right? So when you want to say that something is a horizontal asymptote, you just say that the limit as x approaches infinity of f of x is equal to that number. Vertical asymptote, you just need one of them to be true. That's where we do our sign chart. We already know that it's a vertical asymptote. We're just looking for proof. So let's see if we can do this. So find all of the asymptotes. Okay, so first thing that I notice about this particular function, this is a rational function. So for a rational function, therefore, the limit as x approaches infinity of f of x will equal the limit as x approaches negative infinity of f of x if the limit is finite. How does one spell finite? Finite, right? So you can't get infinity. If you get infinity, you might get negative infinity the other way. You might get infinity, you don't know. But if you get limit, oh yeah, that doesn't say limit. It just says lim is. I was like, how's that limit? All right, let's do this. So the limit as x approaches infinity of, so divide through by the highest power of x in the denominator. So f of x is going to be the limit as x approaches infinity of 3 minus 5 over x minus 2 over x squared all over 2 plus 3 over x plus 1 over x squared, which a lot of those go to 0, and we're just left with 3 halves. Therefore, y equals 3 halves is a horizontal asymptote. Okay, we don't have to go to negative infinity because it's a rational function. We'd have to get the same answer if we went to negative infinity. The next thing we want to do is we want to test. All right, so I need the zeros of the denominator. Does the numerator factor 25 minus 24? It does. All right, so let's just factor the whole thing. Let's use a different color. F of x. So what I was finding the discriminant there. If you recall, the discriminant is b squared minus 4ac. If that's a perfect square, then this thing factors. I think I got 25. Oh no, 25 minus 25 plus. Maybe it doesn't factor. 20. Does this thing factor? 25 plus 4 times 6. 25 plus 24 is 4. Oh, it does. It's still factored. Well, yeah. Let's just factor it. Okay. Sometimes sometimes you question everything. Like, what is all this? Okay, so if I do mine, I should have just factored it rather than thinking about whether I could. So I get -6 and +1 is -5. I get a -2 at the end. I get 3x squared. Looks good. Does the denominator factor? 2x, x. I mean, I have to do +1, +1. So +1, +1. Okay, good enough. So there are no removable discontinuities, which is fine. And sorry, my other computer went to sleep, so I had to wake it up so I could see what's going on. All right, so sign chart. This one feels more like a number line to me. So I need -1/3, -1/2, -1. Oh my God. So -1, which I know is a vertical asymptote. -1/2, which I also know is a vertical asymptote. -1/3, which is a 0 of the function, and 2, which is also a 0 of the function. All right, so we're checking f. It's like the only time that you really like make a sign chart for f is when you're hunting for your vertical asymptotes. Really, you're just hunting for justifications, right? So negative a billion gives me negative, 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 negative. 4 negatives, so positive overall. Okay, and then everything is to the first degree, so we're gonna have sign changes everywhere. Minuses, pluses, minuses, pluses. All right, so I need to say limit as x approaches -1 from the left, let's say, of f of x is infinity. Therefore, x equals -1 is a vertical asymptote. And let's say that the limit as x approaches -1/2, let's go from the right, of f of x is positive infinity. Therefore, x equals -1/2 is a vertical asymptote. So I think that we found all of our asymptotes. I think 3/2, and I think -1 and -1/2. What I'm gonna do is I'm gonna use a calculator to just like check. Let's see. So let's do a new document, I guess. F of x is 3x squared minus 5x minus 2 over 2x squared plus 3x plus 1. Okay. So what am I going to do? I could do the limit to infinity. Limit as x approaches infinity is in the pi key. Infinity of f of x. I get 3/2. That's good. How am I going to do the vertical asymptote? So let me do domain. Domain. As far as I know, the only way to get domain is either from the normal catalog, where you'd like scroll through everything until you get to domain, or to type in domain. I don't think it's hidden in a menu. Here. Okay, so -1, -1/2, I'm expecting to be vertical asymptotes. Let's just graphically confirm that. Or actually, let's do this. Let's do the limit as x approaches -1 from, we did from the left, and we got infinity. Nice. And then let's change this to -1/2, and let's change it to from the right, we got positive infinity again. And we got it. Okay, so everything that we did checks out. So I think that's good work. What I'm going to do is go back to the notes. I'm going to stop this video here because I feel like maybe it's gotten long. I don't really know, to be honest. I should, on my other computer, I should start a timer when I do these. Or I don't know, there's a clock on my computer. I should just pay attention. But this is the work that we've done so far. I'm going to come back in the next video and finish this page, I think, unless things go horribly wrong, and who knows. But anyway, I will see you then.